everyone. In this video I am going to show you how we can use Excel to solve some problems from linear algebra. I'll show you that there are quite many useful features in Excel that can be really helpful sometimes. In particular, I'll show you how we can find the Faulhaber polynomials for some reasonable number k using Excel. And I'm going to start with introducing you to the operations on matrices in Excel. And assume that we have this simple matrix 1, 2, 3, 4. And the first thing, I'm going to duplicate this matrix. So for Excel, in fact, this is not a matrix. This is just a bunch of cells, right? And each cell has its own address here. For example, this is C2, right? This is C3, and so on. However, if we duplicate this matrix and if we duplicate it as an array, I will show you how this can be done. This can be not just number of cells, but the whole array. So before we duplicate it, we need to choose the place where we place our result. And our result will be the same matrix, which consists of 4 cells. Therefore, I'm going to choose somewhere, let's say here, 4 cells for the same matrix. And when I press equality sign and choose the matrix, and now I'm going to press not just enter, but Ctrl-Shift-Enter. And you see the matrix is duplicated, so you see the same matrix here. But now if we press on each cell of the matrix, you get, here you can see that this is an array B2 to C3. And you see these curved brackets, which show you that this is indeed an array, not just one cell. And this feature of Excel allows us to work with matrices. So if we want now, let's say, to sum two matrices, to get addition of two matrices, how this can be done? We can sum arrays. For example, we want to sum, let's say, this one and this one. Again, the first step, we choose the place where we place our result. So this is the sum of two 2 by 2 matrices, so the result will be again 2 by 2 matrix. So let's say I want to get it here. Let's say this is the sum. And I want to get the result somewhere here. So what I'm going to do, I'm going to choose first of all the place for the result, then press equality sign and choose the first array plus the second array. And press not just enter, but Ctrl-Shift-Enter. And you see I get the sum of 2 arrays. Similarly, if I want to multiply the whole matrix by a number, so this is, let's say, scalar multiplication. And I want to get the result here. For example, I want to multiply this matrix by whatever 3, right? So again, equality sign, choose the matrix times 3, Ctrl-Shift-Enter, and get the result. Similarly, for any linear combination, for example, I want to get linear combination of two matrices. Let's say I want to equality sign, I want to get this matrix, let's say, times, let's say, -4 plus 5 times, let's say, this matrix, and Ctrl-Shift-Enter, maybe 7. So we get the result. Okay, so any linear combination with arrays can be done. Of course, the important part here is that you have to be careful about the size of matrix. You know, for example, it's not possible to add 3 by 3 and 2 by 2 matrix, for example, right? And okay, what about, for example, determinant. Determinant also can be easily found, and the determinant is just a number, and the function for the determinant is m determinant is here, and you need to choose the matrix and press just enter because the result is just one number. So here the determinant of this matrix, for example. What if we want multiply two matrices? Excel also can do this easily. So multiplication. Again, we want to choose the place where we want to get the result of multiplication. And if we want, let's say, multiply this 2 by 2 matrix by this 2 by 2 matrix, the result will be again 2 by 2 matrix. So we choose 2 by 2 array, press equality sign, and the function for multiplication is m multiplication. So you see the functions for, in fact, working with matrices always start with m from matrices, right? So multiplication, and we need to choose two arrays. So let's say this one the first one, and this one the second one. And again, press Ctrl Shift Enter to get the result of the product. This is the product of these two matrices. Okay, what if we want to get an inverse, for example, inverse of a matrix? Excel also can do this. And again, we need to choose the place for the result. And since, for example, we want to get an inverse of this matrix, 2 by 2 matrix, the inverse will be again 2 by 2 matrix. So we choose the place for 2 by 2 matrix, press equality sign. Inverse also will start with m, inverse here, and we choose the matrix and Ctrl Shift Enter again, and we get the result. So this is the inverse of this matrix. And the main drawback here that we cannot get the result in just ordinary fractions. We always get the results in Excel in decimals. And if you want, for example, to get decimals with some accuracy, we choose number, and we can get maybe 4 places, 10 places, whatever we want. So for 4 places, we have this one. And in fact, we have some possibility to move to fractions. However, I do not find them really useful. You see, there are also fraction, and the fraction that we can choose only with the fixed denominator. For example, denominator this one, 110, and so on. For example, if we choose 4 eighths, we get all fractions with denominator 8. This is not very convenient, right? So let's come back to decimals. Number, let's say 2 is enough for us. So the result of inverse is here. Okay, let's now move on to operator that we can use in Excel, the conditional operator if. This is sometimes really useful operator. The operator if, this is conditional operator which has the following arguments. So if the first argument is a logical test, the test that we have to check. And if this test is true, we say the value of the cell will be here, and if this test is false, the value of the cell will be here. Let's look at just simple example. Let's say I want to get here, let's say 1 if the neighbor cell is 0, and I want to get -1 if the neighbor cell is something else. Okay, so I'm going to use if this cell is 0, then please write here 1. If it's not 0, please write here -1. And we have 1 here since this is an empty cell and Excel consider this as 0. If I type here something, you see I get -1. So this is conditional operator, and the first task that we have to do is create a column of alternating 1 and -1. So let's do this. So we need to create a column 1, minus 1, minus 1, 1, minus 1, and so on. And assume that we need quite long columns, so we cannot, do this by hand. This is really annoying. So we want to use operator if. And how we can use it? We type if, and since this is a column and the next cell depends on the previous cell, right? If the previous cell is 1, next one is minus 1, and the previous cell is minus 1, next one is 1, right? So we will use it. We will look at previous cell and say, is it 1? If it yes, then we type minus 1. If no, then we type 1. And now we use autofill, and you see we get the alternating column of 1 and minus 1. And we can do this using this autofill. We can do this until the memory allows us, right? And quite easily. Another important feature in Excel, which will help us to work with matrices a lot, is that each cell in Excel has not just this address, for example, F2, but also the address with two indices, like matrix, like term of matrix. For example, we use ij to indicate the term of matrix. The same is here. If we, for example, take this cell, and if we, let's say somewhere here, we want to ask, what is the row? This is a function of this particular cell. It gives us 2, and this is indeed the second row, right? And if we want, let's say, to ask, what is the column? What is the column of this cell? And it will give us 6. And indeed, if you count 1, 2, 3, 4, 5, F is the 6th column. And if we want to specify, for example, exactly in this particular cell, its row and column, we can use row with empty brackets inside. We get 2. It means that this cell has row 2. And if we use column, it has column 6. And let me show you how this can be used together, of course, with the operator if. For example, we want to draw 10 by 10 unit matrix. So unit matrix is the matrix where we have ones on the main diagonal and zeros everywhere else. So I'm going to use the operator if, and in if I'm going to ask, is row of this particular cell is equal to, and if we start from here, we want, for example, start from here, this is 1, 1 will be here, so the row is 2 and the column is 6, and here the row is 3, the column is 7, and so on. So the row is column sorry, I forgot the equality sign. If the row is equal to column of this cell plus 4, then if this is true, then we get the diagonal element of our matrix. Then type here 1. If this is false, type here 0. Maybe something is wrong. The row is 2, the column is 6, so it should be minus 4, right? So minus 4. So it should be 1, of course. And now if we use autofill to fill this until 10 by 10 matrix, sorry. So 10, that's exactly 10. and 10 to the right, 3, 4, 5, 6, 7, 8, 9, 10. So let me make it a little bit more visible for you. So you can see that we get a matrix with the diagonal elements 1 and other elements zeros. Okay, so this how this row and column can be used to construct some matrices with a given pattern, of course together with the operator if. Okay, sometimes we maybe want to get something where we have to use several if operators. For example, we need to draw a 10 by 10 matrix with 1 on the main diagonal, zeros above the main diagonal, and -1 below the main diagonal. How this can be done? Okay, let's use again the operator if, and the first thing that we will ask will be again if the row of this particular cell is equal to the column, and we have to count exactly, this is 13 row and 6 column, so column plus 7. If you want to get this term to be the first term of the matrix, then these numbers must be the same, and on the main diagonal we must get 1, right? Otherwise, if it's not true, then, and here we have 2 more conditions. We have to say, is it above the main diagonal or below the main diagonal? So again, we have to ask if, and how we can ask that this is above the main diagonal. Above the main diagonal means that the number of column larger than number of row, right? So the row smaller than column, and we have to use this plus 7 because we moved a little bit. Sorry, I forgot the bracket here. If this is true, if rows are smaller, then we are above the main diagonal, and in this case type 0. Otherwise, so we check this one, and this is false, equality is false, the sign less is also false, then we should get the sign larger, right? In this case, we have to type -1. So we close this operator if, and we close this operator, the first operator if, and press enter. Okay, and let's see what do we get. So 0 is above the main diagonal, correct? And we need 10, right? 5. Sorry, there's no net space, therefore make an error. Okay, so you see, indeed, 1's on the main diagonal, 0's above the main diagonal, and -1's below the main diagonal. So this task also done. And this is done using 2 operators if, and again, the possibility to use number of row and number of column. Alright, and now I think we are ready to calculate the Faulhaber coefficients for Faulhaber polynomials. Let me remind you that the first thing to calculate the coefficient, the first thing that we have to do, we have to construct such a matrix, and here we have this matrix until k equals 8. But we can do this until, let's say, any reasonable k. And let's firstly construct this matrix. And to do this, we will use the same idea that we used in previous page. And we split this matrix into three parts. You can notice that we have here the column of alternating 1 and minus 1. We have here zeros above the main diagonal. We have here subsequent numbers along the main diagonal. And these numbers are quite special. And what is special in these numbers? The first thing, these numbers are the sum of absolute values of these numbers. So 3 is 2 plus 1, for example, 10 is 6 plus 4, 5 is 4 plus 1, and so on. And also there is a sign, and the sign will be determined by the diagonal here. For example, in this diagonal we have only positive numbers, in this diagonal only negative numbers, and so on. So we split this into 4 groups, and for each group we will use operator if to ask. Let's maybe start with the this cell. This is 2, 2 cell. And we start here typing if. And the first thing that we're going to ask to construct this 1 minus 1 column. And this column will be in the column B. So in the column with the index 2, right? So if the column here is equal to 2, then what should we do? We should use also if. So if the column is equal to 2, then we have to construct this column, right? So if this is equal to 2, we type if the previous cell is 1, we type minus 1, otherwise we type 1, right? So this is in the case if the number of column is 2, so this is in the case of truth. If this is false, then we are in some other part, one of these three, right? Let's firstly check the condition for being upper the main diagonal. If the number of row is smaller, strictly smaller than the number of column, then we know that we must get 0, right? What if it's not? Then we are in one of these parts, on the main diagonal or below the main diagonal. If we are on the main diagonal, so let's check this condition. If the number of rows coincide with the number of columns, then we are on the main diagonal, and here the number depends on the previous in the diagonal number, right? For example, if it this cell, then this is this 3 plus 1, right? So we can write, in this case, take this cell on the diagonal with this cell and add 1 to it, okay? If it's not true, if it's false, then we are definitely now in this part, because we checked already this, this, and this, right? So we are definitely in this part, and we have to say Excel what we should do. So, for example, to get this 3, we need to add absolute value. So this is ABS in Excel, absolute value of this number, add with the absolute value of this number. But this is not enough. We also have to care about the sign. Okay, so let's firstly take this expression in brackets and multiply it by sign of the diagonal element. So we have also the function for sign. Sign of the diagonal element, of the element on the same diagonal with this term. Okay, and we have to close this if, and this if, and this if. And next we press enter. We get 1. Why do we get 1? Because the first we have column 2, so we go to this if, and b1 is 1, no, so we get this one, right? And now let's autofill this until, I don't know, maybe let's say 5, 6, 7, 8, 9, maybe 10. And we get zeros here because we are above the main diagonal, and we are not in this, so we go to false part. And the number of rows is smaller than the number of columns. Yes, we get zeros, right? And let's autofill the other part of the matrix. So we choose 10. So let's write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, we get this matrix for k equals 10. And we can, of course, do this for any reasonable k. We can extend this matrix as soon as our memory allows us to do. Of course, it's not possible to go to infinity, but it's possible to go to some reasonable numbers. So this is how we can construct the matrix that we need to determine the Faulhaber coefficients. And next step, we have to find the inverse of this matrix. And we already know how to find the inverse. The first step that we do, we choose the same place with the same number of cells. So this is 10 by 10 matrix, so we choose 10 by 10 array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Press M inverse. We choose this matrix here and press Ctrl-Shift-Enter. And we get the matrix. However, you see that the numbers are not so beautiful. We need to go to make it number, and we can choose the accuracy that we need for our task. So, okay. And you see we get these numbers in the main diagonal. 1, a half, a third, a fourth, and so on until 1/10. Above the main diagonal we get zeros, and below the main diagonal this one is Bernoulli sequence, and these numbers are Faulhaber coefficients. So this is coefficient of n to the 10, n to the 9, n to the 8, and so on until just n. That's it for this video. I'm Anna Tomskova. Thanks for listening.